Alright, problem number 9. We have A through H, almost going through the whole alphabet. We have 8 parts here. And we want to first find the solutions in the set W. So W is whole numbers that will satisfy the given equations. So I guess when you're teaching elementary, we don't know algebra yet, but what we want you to be able to do is use some method to get them there. So we're going to take x minus 12 and set that equal to x plus 2. Okay, so what we want you to first do is take these two numbers, 12 and 2, and we're going to subtract them. And we're going to know from this equation that whatever x is going to be less than this difference. I can't subtract 10 and add 10, it's going to be too big, so it's going to be something smaller than this. So this gets you a starting point, so we know we have numbers less than 10 that we're going to be dealing with, and then from there we just need to figure out which number to use. So with some trial and error, we should arrive at 5, just kind of plugging in. So if you try this out and you just pick different numbers, that's one of the first ways you learn math, is trial and error. You plug in some numbers, 12 minus 5, that gives us 7, and 5 plus 2 gives us 7. So you just start out with subtracting them and finding the difference when you have this set up, and then that gives you a upper bound, and you try numbers smaller than that, and with trial and error you will get to 5. Okay, so 5, and in this case you don't have to try every number smaller than 10. You have multiple choice, but we should arrive at 5. Okay, now part 2, I'm going to be using some different methods. They want us to use the properties of associative property with the grouping. Okay, so we have 8 minus x. Now we know we have the associative property for addition. It can be somewhat translated to subtraction if you think about adding a negative. So we're going to regroup these. We're going to kind of just switch the order, associative and commutative property all together. So we're going to rewrite this as 8 minus 3 and then subtract x and say that that equals 2. So this is a method they want you to use, and this will give us a difference of 5. And now it's kind of easier to see the solution when we're dealing with smaller numbers. So 5 take away what is 2, and then we can figure out that x has to be equal to 3. Okay, part C, we have 4 plus x is equal to x plus 4. Okay, so again we'll be using one of those properties, so we'll use the commutative property just to rewrite this, and it just says we can change the order. So if we write x plus 4 over here, leave this side the same, okay, we can see that both sides are going to be equal no matter what number, because we're adding 4 to both sides. So since that's the same, no matter what number we plug in, it's going to be the same. So this equation will work for all numbers. Okay, so part D, another one of those properties, we have 9 minus x equals 0. And so the only way we get 0 from the property is if you take away itself. So in this case, x has to be 9. 9 minus 9 will give us 0. Okay, part E, we want to manipulate this equation again, kind of using those properties of associative and commutative. 7 minus x Okay, so we want this side to look like this side. So we can break up 14, we can rewrite it and get a 7 out of there if we do 7 plus 7. Okay, so I'm going to rewrite this as 7 plus 7, that's still my 14, minus x equals 7 minus x. So now I can see that we have a 7 minus x on both sides, but this side has an additional positive 7. So no matter what number I plug in for x, these two sides will not be equal. This side will always be 7 greater. So in this instance, there will be no solution, no one value that I can plug in to both sides to make them equal. Okay, part F, we have x minus 2 equals 15. Okay, so this is just a straightforward counting problem. We have some number, we're going to take away 2 and get 15. So you can kind of use number lines and say if I go 2 more this way, we'll end up at 17. So x has to be 17 in this case. Okay, with G, again, we're going to use some manipulation to this problem to try to get these sides to look the same. So I have minus 1 over here. I want to have a minus 1 here. So what we can do, I'm going to rewrite this as 5 plus x equals x minus 1. Okay, so in order to get a minus 1, I will take away 1 from this side, so I have x minus 1. But if I subtract 1, I have to add 1, so that will be the same as like adding 0. So plus 1 minus 1, those will cancel out, and I still end up with the same thing. So I'm just doing this to manipulate so I can get it to look similar to this side. So then what I'm really looking at is 6 plus x minus 1 and x minus 1 over here. So you notice we got these two being the same, and then this side has an additional plus 6. So this problem again will have no solution because this side will always be 6 greater than the other side. So no solution here. And then H, this will be our last part. We have 0 plus x equals x minus 0. So the identity property with addition says if you add 0 or take away 0, it's equal to the same thing. So over here we just end up with x. Over here we end up with x. Both sides are the same. So no matter what value of x you plug in, everything will work. So the solution here will be all whole numbers.